Hi, my name is Yolita, and the digital technology that I will be presenting today is called GeoGebra. The Australian curriculum outlines and set out the national standards for expected learning outcomes for students from kindergarten to year 10. In this project, I will be focusing on 2 year groups, year 1 to 4 and year 5 to 7. The digital technology GeoGebra has many modern and convenient features that will allow students from year 1 to 4 to construct and explore in geometry in reference to the topic shape. Year 5 and 8 will also be continuing to learn about geometry. However, they will be learning about geometric reasoning. Geometric reasoning is the use of critical thinking to identify different types of triangles, name, measure angles, sum of triangles, and quadrilaterals. GeoGebra has a lot of benefit when it comes to assisting students to achieve those outcomes set by the ACM. This is because the use of technology plays a huge role within the learning process for a variety of subjects across the curriculum. So more of the elaboration in reference to measurement and geometry from the Australian curriculum mathematics will be explained more throughout this presentation. This software allows students to focus on geometry in reference to shape, as the Australian curriculum states that students from year 1 to 4 must be able to describe and draw two-dimensional shapes with and without digital technologies, meaning that students must be able to recognize the main characteristics, such as counting the numbers of corners, edges, straight or curved lines, from two-dimensional shapes such as triangles, squares, rectangles and rhombus. Therefore, a form of digital technology software such as GeoGebra would be suitable in assisting students from year 1 to 4 to achieve the learning outcomes set in the ECM. GeoGebra has many features within the software where students can easily construct two-dimensional shapes, allowing them to visually recognize and describe all the main characteristics of the two-dimensional shapes they have created. Students from year 1 and 4 also requires to describe the features of three-dimensional objects and recognize the familiar two-dimensional shapes and three-dimensional shapes object, meaning that students must be able to construct three-dimensional shapes and recognize its characteristics such as its faces, edges, and corners. This approach outweighs the traditional approach of getting students to physically draw out different shapes because it can be time-consuming and complicated for some students as they may not have the ability to draw the correct dimensionals or three-dimensional shape with the correct features, such as the correct amount of corner, edges, or straight lines. Students can create this shape easily in GeoGebra by simply dragging lines in order to construct different shape. This digital technology is also more engaging than the traditional approach, as this software has many advanced and modern features within the software that is interesting, making it convenient for students to explore, and is more engaging than the traditional approach of just using pencil and paper. Students can also work in pairs to create construct and explore within this topic in GeoGebra and share it with their classmate, making it interactive and engaging for students. So right here is the 2D shapes that I have created by simply joining the coordinates line and link all those lines together. And then here is also another example of a 3D shape, so students can easily construct 3D dimensional shapes by simply selecting the 3D graphics window on GeoGebra. On the tools tab, select the desired 3D shape that they're going to be construct, and then on the 3D graphics scale, click on 2 locations to place some points. Then the cube will be created. So from here, from creating the 2D shape and 3D shape, students can then identify different characteristics of 3D shapes and 2D shapes, like it's counting faces, corner, edges, straight lines and that, and compare it, both shapes together, which will obviously help students achieve the outcomes set by the ACM. Now we're moving on to the year group 5 to 8, where students will still be using GeoGebra, but they will be studying a different topic other than shape, which is more complicated, and it is geometric reasoning. So geometric reasoning is the use of critical thinking to identify different types of triangles, name and measure angles, sum of triangles, and quadrilaterals. The ACM also states that Students from year 5 to 8 must know how to investigate with and without digital technologies, angles on a straight line, angles at a point, and vertically opposite angles, and to demonstrate that the angle sum of a triangle is 180 degrees, and use this to find the angle sum of the quadrilateral. This means that students must be able to recognize the size of a right angle as 90 degrees and know the differences between obtuse, acute, reflect, and straight. The digital technology will allow students to create different types of angles so that students will be able to easily identify and visually explore the differences between the angles they have created. And this software will also work out an accurate and exact angle that the students have constructed. So this digital technology is more efficient than the traditional approach, as it allows students to manually construct different angles and triangles that come with the angle that has been calculated by the software. This feature of the software is something that is convenient, straightforward, and it allows students to automatically identify and describe different triangles confidently instead of leaving them to second guess if they have drawn and measured the correct angle if they were to draw it out on paper. The use of digital technology is more engaging than the traditional approach, as the software GeoGebra has many interesting modern features that students are familiar with, making it easy for them to navigate. As you can see here on an example that I've created an angle of 75 degrees. So all I did was choose a segment with a given length option and choose any length for that line. Segment should be point A and B, and once a horizontal line is created, students go to the tool tabs and choose angle with a given side option and choose point A and point B and set to any desired angles that they would like. An angle is then created, so now students know how to create different angles from the line segments. They can now start to identify, describe different types of angles such as obtuse, acute, reflex, and straight, which will support the learning outcome set by the ACM. And here is a second example where I've created an 180 degrees angle. So from here, students should, like I mentioned, should be able to identify the differences between different angles, and eventually they will be able to create triangles with them. And here is simply how students can create a 2D shape. So students need to simply press on the polygon button. They will then need to find the coordinates and insert the point, so point A, and on the grid paper, on the grid graph given, and then point B, point C, and then connect all the lines together and it makes a triangle. And here is another example where students can create a 3D shapes. So simply students just need to click on the top bar and select what kind of 3D shapes they would like to make. So in this case I want to create a cube, so I just click a cube, and then I click the 2 points on the axes and a cube will be created for them. So from here, students should then be able to identify different characteristics of the 2D shape and the 3D shape and compare them, see the different faces, corners, edges, and hopefully this will help students to achieve the learning outcome set by the ACM as mentioned previously on the slides. And now for example number 2 for students from year 5 to 8, where students will be learning about geometric reasoning as mentioned before. So they will be creating angles. So students will need to go to select a point. They would then need to select a segment line from point A to point B. Students will then go on the angle tab and select angle with a given size and select A point to B point and then insert the angle that they would like to create. So for my case I am creating a 75 degrees angle clockwise. And there it is, there's an angle that we have created, and to make it easier to look, you can add a line and there is a 75 degrees angle. So here is just another example of a 180 degrees angle. So I will select point, segment with a given length. Let's say we want our length to be 6 centimeters, and then we want to create an angle from point A to point B, which will be 180-degree angles clockwise, and there it is, 180-degree angles to make it easier to see. There is a complete straight line at 180-degree angles. So from here, students should then be able to identify different angles and what it means. They should be able to describe, if it's a obtuse, acute, reflect, or a straight line, which will hopefully support the learning outcomes mentioned in the ACM as well. And here is my personal stance on the use of technology being integrated into the classroom. So the reason I believe that it does have a positive outcome is because it has increased students' motivation to learn, as different digital software contains many interesting, exciting features that will allow students to explore and create a project that is relevant to the topic they are learning at school. It will also allow students to engage more with their peers, collab, and learn with more with their classmates and develop team building skills, while using pen and paper and getting students to physically draw and learn about different aspects in geometry can be hands-on experience for kids to explore and learn. But I believe that using technology definitely outweighs the traditional way of using pencil and paper, because technology can assist in measurement and geometry and is more straightforward, convenient, and accurate, allowing students to construct a more accurate result and explore different aspects of measurement and geometry and other geometric relationships. As mentioned before, technology is now being used more than ever by both adults and kids. Therefore, by including technology in the classroom and use it as tools to assist students across the learning areas, especially in maths, will increase technology skills and prepare them for future, both in school and career-wise as well. And here are my references, all the content description for year 1 to 4 and year 5 to 8. And thank you for listening.